Now recording. So, PHP. So, we are about to dip our toes ever so gingerly into the vast ocean which is server-side programming. Up to now, everything that we have done has been client-side programming, right? Everything that we've written so far is designed for execution on your own local computer. PHP is a server-based programming language. So, it presents a very different, interesting, and unique set of programming problems and challenges. One of the most important things about server programming is that security is now a top-line concern. Security on the client, you can always only do so much because fundamentally, any code which is downloaded to the client may be viewed and modified freely by anybody who downloads it, including a malicious attack hacker. With PHP, we are now programming in a more secure environment. With PHP, none of your PHP source code is directly transmitted to the client. It executes, runs, and disappears on the server before it ever makes it out to the network. So, it is possible to do real security on the server in the way that's not possible on the client. Is this making sense so far? Good. Don't worry too much about security. We'll talk about the topics as we move through, but I would like to sort of put a fine point on it. All of you in this room, all two of you in this room, are you're going through this degree to be working in the healthcare field, right? People's medical records are valuable data, valuable targets for attackers, and you will be under a certain amount of legislated requirements for keeping the data of your clients secure, right? Like, data security takes on a whole new meaning when you're talking about people's medical records, right? So, just keep that in mind. Security is not optional. All right? So far, so good? Good. So let's start with what PHP stands for. So PHP stands for PHP Hypertext Processor. So the P in PHP stands for PHP. It's a recursive acronym. This should initially give you some flavor of what this language is all about. Originally, PHP stood for Personal Homepage back in the 90s when it was created by one Rasmus Lerdorf. Programmers have the best names. So, the idea with PHP is that it is executed/interpreted on the server in response to HTTP requests, and the results are sent back as a response to the client. So, this is generally how it goes. So, classically, you may have heard me say this before, but it is still true. In the classical conception of the internet is essentially a great big distributed file system, right? When we make an HTTP request, what is it that we are requesting in a web classic sense? Anybody? Okay. A file, that's right. We are requesting a file on the server, right? So, in particular, in the original conception of the internet, we were requesting hypertext files, right? So, basically, I would request index.html, right? The server would go and find a file called index.html, and it would load it up, queue it up, send it off in a response packet. The response packet has the file attached. Making sense so far? So far, so good? So, what happens with PHP now is that we add an additional layer of processing, general computing, sandwiched over here. So when we request a PHP script, it's got a PHP file extension. So index.php, right? The same thing happens on the server initially. Index.php is found inside of the server's file system. So far, exactly the same. Here's the difference though. This file then gets thrown into, what do I want to do? Let's give it a little gear icon to show that this is a process. This is the PHP interpreter. PHP interpreter. The PHP interpreter interprets PHP code in the same way that the JavaScript interpreter interprets JavaScript code, or the Python interpreter interprets Python code. We are in interpreter land, right? PHP is an interpreted language. Fundamentally, what PHP is good for is text manipulation. What it's been designed for is to manipulate the specific HTML code which corresponds to the file. So, PHP, the PHP interpreter will then produce HTML code, although the file name will still be index.php. So, as the PHP interpreter runs, it takes all of the PHP script out. There's no PHP left in this file by the time this guy is finished with it. This then gets sent back up into the server's, packet marshalling. It makes a packet, it sends the packet back to the client using all of the networky type stuff that we don't really care about in this classroom. I can wave my hands and say networking mumbo jumbo. So, does that make sense? We are putting the PHP interpreter as an intermediary step between fetching a file and sending that file back. Make sense? Good. So, PHP is an older technology, although it wasn't quite as old back when when these notes were put together. Similarly to jQuery, PHP isn't the cool new technology anymore, but it is foundational, important, and widely accepted. Widely accepted as being terrible. What if we go to Google, PHP meme? Let's take a look at some of these. Here we go. PHP best practices, page 1, use something else at the end. What's another one? Here we go. That's a good one as well. Everybody hates PHP. So, basically, programming languages never die, even if they become unpopular. There will always be employment for people who know PHP because of the large base of legacy code that PHP has built up over the years. Even if there are newer, nicer technologies, PHP, it's also used to power some very popular frameworks. WordPress, Joomla, Drupal, and Laravel, which we'll be studying later on in the course. All of these are based in PHP as well, although many of them, what the point of using a framework is that it minimizes the amount of actual PHP programming that you have to do. So it's written in PHP, but it's kind of attempting to get away from having to write vanilla PHP. 83.1% of websites use PHP. Well, that might be different now, but yeah, this is an old report. But there we go. When files like HTML, JavaScript, and JPEGs are requested from the web server, they are sent back in a response unaltered. When a .php file is requested, the server will call the PHP interpreter to execute the PHP code inside of the file before the results of that file are returned, before the results of that program are returned to the client. This allows for dynamic web pages, i.e., interesting things that can now happen programmatically. It also allows us to interpret input, query databases, generate results, and save things to files. So there are lots of things that you need something running on the server to be able to do. One, accessing databases. There's basically no way for a client to be able to access a database directly. This would require us to give database credentials to the client, which is a terrible idea because clients are often nasty people. So, all database access needs to go through a server-side programming language, such as PHP. So, if you consider making So let's imagine that you have a website and you want to have like login capabilities as well, right? The only way to do a login session to authenticate a user, first of all, you need to have a database, but second of all, you need to do session management. Session management is also something that you do on the server, right? It's not something that you do on the client because it has to be secure. Good. So, basically, so I'll extend this diagram for just a moment to indicate that the PHP interpreter has access to the file system on the server. It has access to databases, which are often other server processes. Databases are usually represented as a series of stacked cylinders. And you can also connect to things like email servers. You can send and receive information from all of these sources in a PHP script. Again, something that's not possible while we're only stuck in client land. Make sense? So far, so good? Don't fail me now. There we go. Ta-da. So, this is a piece of key terminology when you are looking at job descriptions. All right? Technology stack. If you're looking at a job description for a back-end or a full-stack developer, very often you'll see a 4-letter acronym, which is an indication of which technologies your application uses. Many of these technologies are interchangeable with each other. The acronym is these acronyms, they don't always put the same things in the same places, frustratingly enough. But an example, the stack that we are going to be learning so far in this course is the LAMP stack, standing for Linux as an operating system, Apache as a web server, MySQL as a database, and PHP as a server-side application language. That P can also stand for Perl, but if you want a language that's even older and less used than PHP, just look at Perl. Perl, have you guys heard of Perl? No? Perl is interesting because it's basically the language that invented, it had a really good regular expressions engine, which everybody ended up using. Perl, the Perl programming language. Perl was succeeded by Ruby, and most of the time when people use Ruby these days, they use a Ruby framework called Ruby on Rails, or sometimes just Rails. So, alternative technologies. So, The interesting thing about programming on a server is that you can find a backend for a server in pretty much literally any programming language. You can find a backend in Java. There are several popular Python ones, Django and Flask, I believe. C#, C++ even. You could even do C if you really wanted to. Any programming language can be a server-side programming language. But unlike general-purpose programming languages, languages like PHP and things like Node.js they were designed to be server-side programming languages from the beginning. Therefore, they are best suited for it. They are domain-specific, application-specific languages. They are designed to make the tasks related to server-side programming easier. Make sense? Another popular technology stack is the MERN stack. The MERN stack, let's see here, yes. There we go. Mean stack, MERN stack, MongoDB as a database. I believe that's Express Express or Angular for the Express for the framework, Node for the front for the back end, and React for the front end, or possibly Angular. There are lots and lots of different interpretations, but that's another popular one, MERN or Mean. So basically, how this applies to job searches. Your job as a developer is basically, if you're going to be a full stack developer, your job is to specialize in one of these stacks. You pick one and you go for it, right? It's possible to know development in a couple of these, but there are a lot of different combinations, and generally what you want to do is you want to specialize in one or two of these combinations of technologies, and then go after job applications which are, they'll list which stack they're using in the job application, and you target yourself to the stack that you are an expert in, right? These technologies take time and effort to get good at, right? So it's unreasonable to expect yourself to be an expert in all server-side technology, all full-stack technologies. It's just, one might need several lifetimes, right? So you pick one and you go for it, usually a popular one, and that's usually how it goes. Make sense? Cool. So, these are two different ways of viewing the LAMP stack. Linux is your operating system. Apache is the web server, Apache web server. What's meant by the web server, it's the thing that receives the packets. It's the thing that finds the right file in the file system that's been requested. It's the thing that creates the response packets and sends them back out again. All of that, listening to ports and all of that stuff, that is the responsibility of the web server. The responsibility of PHP is to execute PHP code and produce the HTML file, which will be sent to the server, or to the client, pardon me. So the purpose of PHP is to produce a web page. The purpose of the SQL database, if you're using a relational database, or if you're using any database really, is to hold data. Hold data so that the PHP process can look that data up. It is unusual to keep large amounts of data stored inside of a web server. The SQL database will be a secondary server process running inside of the same operating system. So you may remember me saying from early on in this course, servers are not hardware, servers are software. The thing which actually does the listening is a software process, not a hardware process, even though we typically think of a server as being a specific type of computer with no monitor and no keyboard, right? So, inside of this Linux operating system, 2 of these blocks inside of it are actually servers. SQL and web server. Sound good? And this diagram basically expresses the same thing. The PHP the PHP process requires the Apache and optionally the SQL server, and then your application runs on top of that. So, have we discussed what is meant by the term web application? This is probably a term you've heard before, web application. This is kind of the modern lingo for it. We don't necessarily just mean websites when we talk about web applications. It can include other things as well. Although, a lot of the time, like a web application might be a phone app or something like that, but a lot of the time those phone apps will just be stripped down browsers that you can't request other URLs in. That's kind of often how it goes. Using, what's the thing you use for that? React Native, or possibly Electron. Electron is a framework that can take a website and turn it into an app, basically. So the web application, quote unquote, is comprised of both the client-side software and the server-side software taken in combination. So the web application, in contrast to an application, like Sid Meier's Civilization 2, for example, in an application in the classic sense, all of the source code is located in the same place, right? And it always has access to itself because it's always on the same system. In a web application, half of the source code, or whatever the percentage is, but half of the source code is running on the client machine. The other half of the source code is running on a server. And it is the communication between those two that provides that interconnectivity that used to be provided by a file system. Does this make sense? So web application means both client-side and server-side code taken in combination. Make sense? Okay. Good. So, we have made our way through to the hello world. It only took us a half an hour. So, this is your PHP hello world. PHP gets mixed in to HTML in kind of the same way that we mix a JavaScript tag into HTML. We have a special, basically a special tag. It starts with opening angle brace. Then you have a question mark, the term PHP. Then you have PHP code, question mark, closing angle brace. that is a PHP tag. We are not using print. We are not using console.log. We are not using debug.log. We are not using printf. The way that you print information in PHP is using echo. Would you like to know why it's echo? I know the reason. Yes?
Is it because it's kind of translated into HTML? HTML is echoing what PHP is saying?
Yes, like it's not a horrible description of what it's doing. But the reason that the word echo is used over something like print is in Linux, in a bash environment, echo is a bash command that prints information, basically. So, shall we get that operating? If everybody could please open up Mohawk Apps. I have to introduce you to a new piece of software. So, while we could write our code and upload it to an Apache web server such as CS Unix, more often than not, you want to do your development on a local environment. It's difficult to lock down a web server so that so that your work in progress code, your broken code, isn't viewable to people in the general internet. It's always good to develop the application in a local environment, and then, only when you're sure it's good, as free of bugs as you care to make it, only then do you push it out to a real hosting service. So, we have a piece of software called XAMP. XAMP is actually the name lamp, but with the L replaced with an X. The X means cross-platform. So essentially, XAMP is a way of running the LAMP stack on any operating system. Windows, Linux, Mac, anything. What the thing is essentially doing is it's emulating a server on your machine, and it's not allowing the network process to communicate with the actual real network. Basically, everything is accessible through localhost. So, when you launch XAMP, has everybody got XAMP launched? Still working on it? Downloading it? Good. You will see you have several server types available to you. In this course, we're really only concerned with Apache and MySQL. And we're not even concerned with MySQL yet. So, if you could please click Start to start your XAMP server. Don't worry about the Windows firewall thing. If you click Cancel, it works for some reason. Good job, Windows Firewall. So there you go. We now have an Apache server running on our local machine. So far, so good. Yeah? Good. We can see that our Apache server works if we go to localhost. Oh, site can't be reached. So, do you folks, did they show you how to put the port numbers into a URL in networking? No? Okay. So, if you take a look at our XAMP interface, it tells us which ports this server process is using, right? In our case, I think it's outgoing is 443 and incoming is 1080. So you can specify which port you want to access using colon. In this case, 1080. And you can see, if we load that up, we have our Apache dashboard page. Does this make sense? I'm just going to take a moment to see that you guys have got that loaded. Yes. Very good, very good. Still downloading?
Yeah, my Mac is giving me a hard time with downloading it. It's telling me can't verify it, so I'm just trying to figure out how to verify it.
Might be easier to this one for the purposes of the lesson. So, the way that the Apache server works, there is a particular folder inside of the XAMPP installation folder. That folder has been designated as the publicly accessible file system. Like that directory is the stuff you can access from the internet or from localhost anyways. So if you go to Explorer on the sidebar, that gives you XAMPP's installation folder. If you then go to the folder htdocs, which stands for hypertext documents, you can see our dashboard page is there. For our purposes, we actually don't need any of this stuff. We can delete it. And let's add a simple little HTML file just to show you how the server works. New text document. Call this index. Let's call it mypage.html. There we go. HTML and HTML. Body and body. Oh, I forgot head. Head and head. There we go. Into the body, let us place a heading. This is a website. There we go. Some text on a website. Now, if we access localhost again, leaving off the /dashboard, which doesn't exist anymore. Uh-oh. Bloody Windows. View file name and extensions. Rename. It should be called .html, not .html.txt. There we go. So, this is a very important page inside of an Apache server. So every directory inside of an Apache server that does not have an index page produces this page by default. This is a view of the contents of that folder. You can see we have mypage.html, which is the HTML page. If we had an image in there, that would be showing up here as well. We can access this by clicking on it. You can see all that that's doing is putting the file name into the URL. Make sense? So this page is now accessible through XAMPP. Now there is a critical difference here, an absolutely critical difference. Difference between this and how we've done this so far. When we have created a website before using XAMPP, the way we would view it is right click, open with a browser, there you have it. Now I'd like to point out the difference in the URL. First it calls it a file, then it gives the C drive address of that file. Note the difference. Here, this is an HTTP packet response. We are accessing it through localhost, not through the C drive. Make sense? Any questions? So, why is this important? In order for PHP to execute, you have to go through the server. Opening the file locally will not execute PHP. It will not execute the PHP scripts. Yes. I changed the file name, didn't I? There we go. So, let's now enable PHP for this HTML document. The way that the server knows that the file contains PHP code is that it has the .php file extension. We can now use PHP tags. PHP, echo, hello, from the PHP interpreter. There we go. Oh, HTML doesn't exist anymore, which is true. mypage.php. You can see, hello from the PHP interpreter. There you go. We now have a working PHP hello world. And that only took us 15 minutes. So, any questions?
I missed the part where you were actually opening the file.
So start Apache. Now go to Explorer. Just cancel. Go to Explorer. htdocs. Delete all. Index. No, delete all of that. Make a new file in that directory that's your HTML file. Text document. going to give you the wrong file extension, so.
I just do this PHP.
Yes. .php. Enter. But see, it's php.txt. Get rid of that too, and then just copy my source code. There we go.
What am I looking at with?
Notepad++ or VS Code, whatever you like. It doesn't matter. Did you get it working? There you go. Oh, we deleted the dashboard folder, so it doesn't exist anymore. Also, let's address your file extensions. New file extensions. It will need to be named mypage.php. Otherwise, the server won't run it as a PHP script. Get it working? It's currently called php.html. You know how many times I've complained this semester about this? If you enable file name extensions, then you can actually change the actual file extension. So, there you go. Looks like that should work. There you go. Hello world. There you go. Good. Any questions? Did you get it working?
Go to open it, it's not, oh, no, never mind. It wasn't doing it, if you code or anything as an option. Possibly because I never actually looked it up in my account on the computer, but it just opened it up naturally.
Okay. I hate cloud apps. So, a very important principle that underlies PHP is that fundamentally what we are doing is we are writing things into an HTML document. What this echo statement does is it replaces this PHP tag with the echoed string. It replaces it in place. We can see this if we take a look at the HTML code in this website as received from the server in the inspector pane. So notice, just like in the HTML that we wrote, we have a paragraph with 2 lines, closed paragraph. Then we are there's our echoed statement. But notice, this does not have paragraph tags, right? Why doesn't it have paragraph tags? Because it didn't in the source code. This string was replaced in place. We can put We can echo HTML tags as well. For example, let's make this an H3. There are actually two ways you can do this. You can either put the H3 tags inside of the echoed string. It also works to put them outside and wrapping the PHP string, or the PHP tag in this case. But this kind of demonstrates what I want to demonstrate a little bit more. There you go. Hello from the PHP interpreter is now heading 3. So that is a very important point about PHP. We are not simply echoing text. We are echoing full-blown, full-bodied HTML tags. We have the full expressive power of HTML at our disposal. Not only that, PHP can also construct CSS rules and JavaScript. Though, we will not really be using PHP to do that. It's a bit of a weird edge case to generate JavaScript using PHP. It can be done, but it's kind of, JavaScript is already sufficiently expressive. Why would we need to kind of question, But anyway, does that make sense? Okay, good. So much for our PHP Hello World. PHP code inside of an HTML document needs to be placed inside of special tags. There are two formats for these tags, either with PHP or without. Note, for the PHP code inside of an HTML document to be executed by the server, the document would still need to be saved with a .php file extension, not HTML. And as we saw on Windows, that can be particularly tricky because it hides your file extension by default. You must always be aware of the file extension. Basically, what the Apache server does is it looks at the file extension to determine whether or not it needs to do any PHP interpreting. Do you need to see the source code yet?
No, I can't get it open, but I got the code.
So the file extension is important. I'm going to come take a look now.
Should I rename it? And then when I rename it, it'll create a new file. So I just copy it.
We get file extension. Perhaps you hadn't saved it yet?
That was very simple.
There you go. So, this slide demonstrates before and after the execution of PHP script. Echo test gets translated over. Echo break gets translated over. Echo yes gets translated over. What's this guy? Anybody remember? Say it louder.
Is it yes
It's a special character New line character, yes. So there are two important characters, /n and /t. /n is new line, /t is tab, like a tab character. How many spaces a tab character gets is, left to the interpretation of the editor that you're using. But so you can see that only when we encounter this new line do we start printing information to the HTML document on the next line. You'll also notice there are no spaces between test, break, and yes. Test, break, and yes. No spaces. Why are there no spaces? Because there are no spaces here. That's the reason. So when PHP writes strings into the HTML document, it does so precisely. You get exactly what you put in, no more, no less. Make sense? Good. So, how do we run it then? Well, we've kind of already talked about this actually. Normally, PHP files are uploaded to a web server in a file folder that the server makes publicly accessible at an intended URL. For example, a folder home/account/public HTML on the server will be made available as somewebsite.com on the internet. So, if a user accesses somewebsite.com/index.php, that will cause the PHP file at home/account/public HTML/index.php to be interpreted on the server and the result will be sent back. So basically, there's a mapping between website addresses and locations on your server. Another interesting thing is this guy, index.php. I have mentioned before that if you have a file called index.html, that file is loaded by default as the index page of the folder in which it resides. It's the default file that will be loaded if you access that folder, right? Index.php serves the same function. If you have index.php in the folder, you don't have to know the name of the PHP script. It will load that one in the folder automatically. So, for example, if I take mypage.php, rename it to index.php, and then access, mypage.php no longer exists, but if I ask for just the server, you'll notice I no longer have to specify index.php. So, while we're on the subject, let's see what has happened. Let's see what happens if we attempt to view this file within the local file system. So, index.php, right-click, open with. You'll see it's already kind of struggling. Man, I hate the way Windows does this. I guess it'll be Firefox. There you go. So you can see it's not quite what we think it is. If we take a look at the inspector, for some reason, Firefox has decided to comment out the opening PHP tag, but it has done so in an incomplete fashion. Probably all it's doing is it's checking for the presence or existence of of tags. It's doing some kind of secondary processing on this, but it's not doing so correctly, right? If I take a look, let's see here. There we go. Control O on a browser will allow you to just open a web page. If I attempt to open index.php in Chrome, you can see it has basically interpreted this thing as a text file, and you can also see none of the PHP has actually been executed. So how the browser will behave depends on the browser. Chrome chooses to interpret this as a text file and just shows you the PHP code. Firefox attempts in a kind of a half-hearted way to make the thing readable. So basically, all of this is failing because we are not communicating with the server. The server has the PHP interpreter, right? So we are doing things in the incorrect manner. We cannot access PHP scripts without XAMPP. Still running, right? Yeah, we're still good. Okay. Any questions? So far, so good? Good. This is a slide on XAMPP, which I've already kind of went through, so we'll skip over that. Okay, so now we're going to get into some PHP language stuff to do with the PHP language. So I'm going to make a new PHP file. New, save this as test1.php. There we go. So the PHP print statement that we had previously, you can kind of consider that like the inline PHP syntax. You can also just write like full programs with, one statement per line, the way that you expect to write programs, by doing this. At the top of the document, you open the PHP tag. At the bottom of the document, you close the PHP tag. Everything in between is PHP code. So let's go through some PHP language semantics. Starting with variables. So I shall demonstrate to you the reason that everybody hates PHP. The first and worst reason, the best reason to hate PHP. All variable names, all of them, must start with a $sign character. Like so. Ta-da! Oof! Am I right? We can echo variables like this. Now if we run this, localhost / what do I call this? test1.php. There you go. I get the number 5. So far, so good. So, variables in PHP behave very similarly to how variables in JavaScript work. They are both dynamic languages, and they are both weakly typed languages. We talked about weak typing, right? Did we? JavaScript has 2 equality operators, triple equals and double equals, right? I honestly can't remember because I'm also teaching JavaScript in another course that's like teaching slightly different things in a different place. So did we talk about double and triple equals? Don't think so? Okay. Well, here we go. So I'll just demonstrate this quickly in the JavaScript console. So dynamic typing, all right? Dynamic typing means the following. If I have a variable, let x equal 10, I can reassign to that variable a different data type. Now, this is not something that you would get away with in C#. In C#, that would be a compiler error. But in a dynamically typed language, the types of variables can change as the program executes. Does that make sense? This is also the case in PHP. Weak typing means that the thing will try to find equivalencies between values of different types. So, for example, 5 is weakly equal to the string 5. However, we also have a triple equals operator. The triple equals operator counts type as well as value. So in this case, integers are never equal to strings under strict equality, so triple equals turns out false. But if we discount the types as if you could do such a thing, the 5 is weakly equal to 5. Now this can cause a lot of hilarious situations. There is a generally well understood and accepted property of equality, mathematical property of equality, right? So stop me if you've heard this one. But if you have A equaling B and B equals C, what can you conclude?
I actually think we did go over this.
Yes. Well, perhaps it's good for review then. This implies that A is equal to C, right? This does not hold in JavaScript for weak equality. Demonstration. The string 0 is weakly equal to the number 0. The number 0 is weakly equal to the empty string. Do you think that the empty string is weakly equal to the number 0? It is not. So weak equality in JavaScript breaks fundamental rules of logic. Yay! Did I mention that the initial version of JavaScript was written in 10 days? That's all the time they spent on it. So, all of this also holds in PHP. However, PHP is an interesting one. So let's try that out, shall we? 5 is equal to 5. what are we expecting to see? Assuming that weak equality holds in the same way that it does in PHP and in JavaScript, what would we expect 5 weakly equal to the string 5 to be? True. Shall we see if we get true then?
But isn't one technically true?
1 is technically true. That is true. However, what about false?
Zero is technically nothing.
I mean, so here is another reason to intensely dislike PHP. So a Boolean true, right? That would be the result of the first one of those. In order to be interpreted as a string in the echo statement, it's coerced to a string value for whatever reason. PHP chooses that the Boolean true should be coerced to 1. All right. What about Boolean false? What is it being coerced to? Well, it's being coerced to an empty string. Why? Very good question, students. Moving on. I don't know why they chose to do this. They probably have a reason, but it's probably bad. So if you want this to return a true or a false result, you actually have to put that in manually. The way that I usually do it is using a ternary operator. Have I shown you guys ternary operators before? They're pretty easy to understand. This is a condition just like you would see in an if statement. This is what this expression yields if this is true. This is what it yields if this is false. It's just kind of a compact little way of doing an if statement inline. However, ternary operators are kind of fundamentally different from if statements in that you can't squeeze a loop in here or another if statement. It just works on expressions. Question?
Can we put anything we wanted to? Is the left half always what it outputs if it's true, and the right half always what outputs if it's false?
Yes.
So if I put false on the left side, it'll output false even if it's true?
Yes. Yes, you could even say I got sleep last night. No, you didn't. You only think you did because of sleep deprivation. There you go. I wanted to make this relatable to parents. You can also put it on multiple lines. But yeah, false. True. There you go. So, PHP kind of sucks. That's what I'm saying. That's what I'm trying to show you guys. PHP kind of sucks. Something simple like Booleans sucks. If you're trying, if you're attempting to work with Boolean literals, it's actually probably less mental work to just use strings rather than actual Boolean literals. Any questions? All right. So, like JavaScript, we do not require a data type to declare a variable. We don't need to say int, float, bool, etc. But unlike JavaScript, we do not even need to specify a scope. There is no let and there is no var. Here you are. So, strings, ints, floats, booleans. Basically, PHP is picking up what the type of the variable should be from the thing that you put in it. Also, comment characters follow the C style. Should be well familiar by now. Same way that comments work in C# and in JavaScript. Arrays. So, if you are declaring an array inside of PHP, you have two options to do so. Either you use the array function, or you put it inside of, oh, that's a typo, that should be a square brace. You put it inside of square braces like a normal person. So, red, blue, hues. You access the individual elements of these using regular square brace notation, similarly to how we've done everything so far. And arrays are zero indexed, just like every other language we've studied so far as well. You can assign to the elements of an array in this manner. So, array, array at 2 is equal to yellow. But let me show you something else that is very interesting. So, let's say we wanted to view the contents of the array. All right? How might we do that intuitively? Well, you might do it like this. Echo array. Shall we see what that produces in PHP? You know when I take that tone of voice that it's probably stupid. Notice, array to string conversion. Array. It tells me it's an array. It doesn't actually give me the content. So have we talked about JavaScript object notation? Have we talked about JSON? I think so. So basically, the way that we have to send this to the server, or send this to the client, is we must first encode our data structure as a JSON object. So we must encode it in JavaScript object notation before sending it off. Fortunately, this is not too painful. JSON encode array. Then, when we send it, we get red, blue, and yellow. Make sense? So far, so good. We can also add to the array using array push. We specify which array we are pushing to and the value we wish to add. There we go. And, oh, parse error. Oh yeah, I forgot a semicolon. By the way, PHP is a language that is horrible for trying to debug anything because it only, it doesn't give you very good error messages. Similarly to how JavaScript doesn't give you very good error messages. So, there we go. You can see we now have red, blue, yellow, and green. Now, you may notice it's considering this all to be one word because there's no space. So we have one of two options. The one that I generally prefer is to echo a break statement. And now I know that you're not really supposed to use break statements, but when you're programming in PHP, it's okay. I give you leave to use break statements when you are programming in PHP, at least for the purposes of determining your output. Sound good? All right. So, there you have it. So, another sort of thing that we have in PHP is the associative array. Associative arrays correspond to map operation, or sorry, not map operation. Well, they call them hash maps in Java, but in Python they call them dictionaries. In JavaScript they call them objects. In PHP they call them associative arrays. But the essential idea is that we have a data structure. Rather than being organized by numbers, this data structure is organized by strings. So we have a series of key value pairs, right? So, for example, let's say I wanted an array to keep track of my shop inventory in a like an RPG or something. Swords, or perhaps copper sword, 5, wooden shield, 7, small potion of healing, 20. So you can see, maybe you can get the idea, that we have a mapping between key values and keys and values, right? So the way that you use this is to say something like, let me just echo in another break statement here. Inventory at wooden shield. There we go. And if we view, get 7, right? So we can access the individual values. Like normally we would put a number here, right? We would put the index of the item we were trying to access, but now we provide one of these keys that looks up the value. Does that make sense? Any questions? Okay. So now to functions. PHP functions are very similar to JavaScript functions. You use the function keyword to declare them. You then provide the name for your function, a list of arguments, the code that goes inside, wrap it in curly braces, and that's a function. So functions work basically exactly the same as they do in JavaScript. Like in JavaScript, they're not required to return a value. You do not have to specify what the return type of the function is. Again, everything is in dynamic typing, loosey-goosey land. Any questions? Okay. So, PHP also contains the standard control structures, while loops, for loops, if else, and if else statements. Oh, it's kind of funny. Another PHP-ism for you. So, in C#, it's if, else, if, else, right? In PHP, that's C#. In PHP, it's if, else if. Else. It also supports doing it this way, but like the native PHP way of writing else if is to leave the space out for some reason. Don't ask me why. Okay? It's fun. PHP is fun. It's definitely a good language. Absolutely, definitely a good language. Switch statements also exist more or less exactly how you see them in JavaScript and C#. So, there we go. Very good. So now, let's see here. Okay. Well, we've reached the end of that set of slides. Does anybody mind if we have our break now, and we'll resume in half an hour? Does that sound okay? Okay. Since we're at kind of at a natural stopping point. Sounds good. All right. Please be back here by 2:02. Thank you. Now recording. So, HTTP request handler. Let me just erase the board. So in the last half of this class, we saw what PHP is, how to execute it. We saw how to do a hello world, do some basic arithmetic. But this kind of, this doesn't yet get us any new or interesting functionality. With all programs, there are two fundamental questions. Well, three fundamental questions. What does it take as input? How does it process? And what does it take as output? Or what does it produce as output? So in the case of PHP, the thing that it takes as input is HTTP requests. HTTP requests can have data attached to them. You may remember when we were doing HTML, we talked about HTML forms. Well, this is where forms come in. It's not the only way to send information to a server, but it is definitely the simplest way to send information to the server. But of course, we can't use that information on the server unless we know how to process it. So, HTTP request packets. So, the HTTP protocol that enables client-server web traffic has multiple verbs or method types to 4 different types of requests. You may remember us talking about GET versus POST requests once or twice. When you type a URL into a browser and hit enter, that creates a GET request for that resource. Often, but not always, when you are submitting information to the server, you will place that into a POST request. Other verbs include put, delete, and we'll be talking about these more when we talk about APIs, REST APIs, and Laravel. So, you may recall one of the advantages of the POST request. Did we talk about structurally the difference between the GET and the POST request? I think we probably did. So when a GET request puts information into an HTTP packet, where does it put it? On the server? Well, the HTTP request is sent to the server, but the packet itself is not on the server. So recall that packets have a header and they have a body, right? Similarly to an HTML page, a header and a body. In the case of a packet, the body is also called the payload. Right? So, in HTTPS, one of those two things is encrypted. Which one is it? The payload, yes. The header contains all of the routing information for the packet, the information that it needs to travel through the network. So, if it were encrypted, every single node in the network that the packet travels through would need to be able to decrypt it, which defeats the entire point of end-to-end encryption, right? The whole point is the network doesn't know the encryption key, right? So the header is not encrypted. The payload is encrypted. GET requests put information in either the header or the payload. POST requests put information in either the header or the payload. Which one is which? Audience participation.
The server would be the header. Actually,
Did you say the server would be the header?
no, not like the.
All right. GET requests. Is the information encrypted or not? Just take a guess. It is not. That's right. So for GET requests, the information is placed into the packet header. Often, in fact, into the URL itself. This information is not encrypted. With the POST request, the information that the client is sending to the server is stored in the payload, and therefore is encrypted. So, let me ask you a question. If you are sending login credentials, do you use a GET request or do you use a POST request? How many people think GET? How many people think POST? Very good. POST requests are generally used when the information needs to be secure. So you might be saying to yourself, why would I ever not want the information to be secure? Right? Well, with GET requests, you can store those requests in the URL itself. This means GET request information can be shared as a link. It can be bookmarked as well. So, for example, there you go. So, if we take a look at our URL up here, I remember doing this with you guys. What does the question mark mean?
That's encrypted?
Nope, not that it's encrypted. The question mark indicates the start of the query parameters. So, question mark v is equal to this code tells YouTube's server that the video being requested is the one with this code. So, if I copy that, paste it in a new tab, I'm brought to the same video. This is not possible with a POST request, right? So GET requests make they make the link they make the websites shareable. They make the provision of GET requests a shareable thing. Basically, without GET requests, social media wouldn't be able to actually link to anything. So sometimes, it's okay for information to not be secure. That being said, if there are any nefarious organizations which are monitoring your internet traffic, anything that comes in via a GET request is fully viewable to anybody on the network. So, you know, just so you know, in case you thought you were getting away with anything, you know, watching something you're not supposed to be watching by putting your browser into, you know, private mode or whatever, guess what, guys? They still know. It's right there in your URL. It's right there in your packet history. Wow, that was a good flip. So, I've never actually seen that video go that long. GET requests can be cached, bookmarked, and remain in browser history, but should never be used for sensitive data, and you can only send a limited amount of data. That's the other thing. That's the other difference between GET and POST requests. POST requests can be used to send entire image files, or any other type of file for that matter. GET requests, because the information is sent in the URL has a character limit. There's only so much you can send in the URL. So, if it's big, it also has to be a POST request. Sound good? POST requests are never cached, cannot be bookmarked, and do not remain in browser history. They can be used for sensitive data and have no data limit. GET requests can have URL parameters, i.e. query strings, to send key value pairs to the server. For example, once again, if you take a standard URL, the question mark character indicates the start of the query parameters. We then can have a series of parameters, name1, value1, name2, value2, separated by ampersands. So, for example, just to break this down a little further, if we take this URL, we can say these are query params. There you go. This might make it look a bit more like a programming language. This might make it look a bit more, you know, understandable what's going on. If you just insert spaces and, you know, I inserted that for clarity, but if you just insert some spaces, you can see how this is in fact just a list of key value pairs. Does that make sense? Further, if you take a look at the network traffic, let's see here. This might be a bad example just because YouTube has so much going on. Ah, there's the original request. The original request is always right at the top. If we take a look, our request URL includes our query parameters, but we may also take a look at the view in the payload. So, query string parameters are one of the things that the browser will show you. You can see V gets this code. Make sense? An interesting thing that you can do with YouTube videos, there's another parameter it accepts called T, which is the offset from the beginning of the video to start playing at when you load the page. So, if that's actually longer than the video is. Let's try 100 seconds. There you go. So, if I ask it to play at 100 seconds, it plays at 1 minute 40 seconds in. And in our original request, you can see our query parameters now are V and T. Sound good? Any questions? Hopefully this is reasonably straightforward. URL parameters can tell a script how to behave. In the case of the YouTube video, the V parameter basically is what entry in a database we want this page to display. The T parameter is an option, right? Really, that's going to be, configured on the client side rather than on the server side. What will be happening there is that, if you have your video and the timeline of the video, if you set it for like T right there, it'll set you to track, it'll set your, your play counter there, and it will start loading forward. But you still have the option of placing the counter backwards. It'll just have to buffer in front of wherever you place the cursor, right? So like it still has the ability to buffer the earlier parts of the video, but it won't buffer that unless it needs to, right? To save memory and save network traffic, right? But fundamentally, the page still has the ability to grab that information. An example here, imagine we have a parameter sort by price or sort by date. You can imagine if we were producing a table, we could produce that table sorted by either of those parameters. Make sense? Good. So, how does PHP pick up these values? PHP supports a set of arrays which are loaded in PHP by default when the script starts up that contain all kinds of useful information about the packet that was sent, including these query parameters. These are called superglobals. Superglobal arrays. So in PHP, the first and most basic of the superglobal arrays is get. So in PHP, if you wish to access the values of a get parameter, you use $_ get all caps, and then you can access the individual values in that as if it were a normal associative array. That is to say, you do not access the elements of this array numerically, but by strings. In this case, the strings, which are the keys in the key value pairs that were sent from the client. So far, so good? All right. Shall we do this then? Shall we do an example? The answer is yes. We are going to do an example. Going to make a new PHP file. Save this as test2.php. There we go. And I'm also going to want an HTML page as well. Let's try this. Save this as formdata.html. So, I suppose we could do it here, actually. That'd be fine. Index.php. There we go. So, I am going to add an HTML form which targets the PHP script that we just created. I'm going to put my T over this side of the room. There we go. So, form, and form. In order to target a PHP script using an HTML form, we have the action parameter. If we provide the name of the PHP script, test2.php for example, when the user clicks submit on this web form, it will generate an HTTP request packet and send it to the location specified by action. We can also specify the method. Method is equal to get. Now you technically don't have to write method equals get. Get is the value of method by default if you don't specify it, but it's good to be explicit about things, particularly when you're teaching a lesson. So, now we need to put some input elements in here. Let's say input type is text. Name is input 1. Input type is equal to numeric. I think numeric works. Let me just look that up. Number. Number. Name is equal to input 2. Then, of course, we need a submit button. Input type is equal to submit. Value is equal to send that data. Here we go. So, one very, very important thing to note here. Name. If you don't have a name, you don't have a key value pair. Name is the key in the key value pair. This is the name of the parameter that gets sent to the server. If you don't specify a name, it won't get sent to the server. We can do an example of that. Yeah, let's just make another one here. Let's leave name out and you'll see for yourselves. So, all right. Shall we see what happens when we click that? There we go. ASDF, ASDF. There we go. And send that data. So you can see our data has been crafted into a query parameter. We have input 1 getting ASDF, input 2 getting 1, 2, 3, 4. What's missing? We've got 3 input things here, only 2 of them represented. Why? Because it doesn't have a name. That's right. If you want it to show up, it must have a name. In my case, I'm just going to delete it. So, okay. So, the PHP script currently doesn't do anything, but it does exist. We didn't get like a 404 not found, right? Question?
For some reason, mine isn't showing us on the page. I swear it's different.
There you go. So now, in our PHP script, I just want to show you how to view the data. The get superglobal is an associative array. We can view both regular arrays and associative arrays by using JSON encode. Echo JSON underscore encode $ underscore get. So now, all this thing is going to do is echo back the parameters that it receives. Hello. 1, 2, 3. And there you have it. Input gets hello, or input 1 gets hello, input 2 gets 1, 2, 3. So far, so good. Does that make sense? So we can now do stuff with this, right? We can do this, we can do stuff in a kind of programmatic fashion. For example, if we wanted to say, if get at input 1 is equal to hello, you can say echo, let's put a break in there. Hello yourself. Lovely day, isn't it? And you can do something else, like else if. Or maybe just make it a regular if. Get input 2 is equal to 777. Echo jackpot. There you go. So now, we go back. Hello, 777, send that data. Oh, uh-oh, parse error. Expecting semicolon. Oop, there we go. Try again. There you go. We can do stuff based on the incoming parameters. Make sense? So, now I have to show you, we have to speak about the dark side of the Force. We must speak about cross-site scripting attacks. So, you may remember, way back, like a couple of hours ago, when I showed you our Hello World program, I said that you can include HTML tags and those will get rendered by the web page. Well, that's all good and innocent, unless. Consider the following. If we go back to our original website, what happens if I do this? So what I have done is I have coded up a little tiny alert box inside of our text box. Boop. Oh, come on. Chrome is playing tricks on me. Let me try this in maybe a slightly dumber browser. This is such an obvious attack, it's probably not surprising that the browsers have some way of attempting to defeat them. Interesting. Oh, I know what's happening. So, when you send specific characters via URLs, they have to be in specific characters. So let me try this. There we go. Encode it. Oop, there we go. Let's try that this time. It's still not. Oh, this is disappointing. Oh no, I know what the problem is. It's because I'm JSON encoding it on the other end. Okay. I know what the problem is. So this type of scripting attack relies on specific characters getting through and being printed on the page as normal, regular text. JSON encode basically is taking some of those characters and altering them, so it requires doing something phenomenally stupid, like this. There we go. Now, if we try the same thing again, oh, come on. Script. Alert. Script. There we go. I got it. So it was not sufficient to just not be you know, I had to not only put it inside of not JSON encoding it, I had to like take the JSON encoding out entirely because it was leaving strange characters in. But anyway, there you go. So the thing that just happened is I managed to execute a JavaScript tag. I managed to enter in a JavaScript tag into a form. The server takes that information, digests it, puts it back in the page, sends it back out again. it gets downloaded by the client's machine and executed as if it originated on the server, which is a bad thing. So what you can do with this, you don't have to necessarily embed an entire program in a script tag like this. You can simply redirect one of these puppies to a JavaScript script that's hanging out on your own server. Using these, you can perform a number of different types of attacks. Stealing someone's validation cookie, right? So you log into the website issues you a validation cookie, which is a special code that tells the server you are an authorized user. If somebody steals your session cookie, then they are an authorized user with access to your account. Another thing that you can do with these is install a keystroke logger onto somebody else's website, right? A keystroke logger sends the list of all of the key presses that have occurred, and maybe even mouse movements as well, back to the hacker's server, from which they could reconstruct your password, see what it is that you're posting, all of the stuff. Of course, it needs to be, because of the impermanence of JavaScript, if the page is reloaded and the script goes away, the nasty malicious script. But this, my friends, this is how phishing emails work, right? So the purpose of a phishing email, well, there are kind of two broad categories of them, right? One type of phishing email is they will want you to open up a Microsoft Office document, right? Don't open the attachment. I'm sure you've all heard don't open the attachment. And I'm sure that all of you have heard don't click the link. The reason you don't want to open the attachment is because there's an exploit, a long-standing exploit in Microsoft Office where macros, document macros, have like way more system permissions than they ought to have and can do strange things like install viruses on your registry, that kind of thing. Actually, there's a fun little graph I like to show people on that subject. If you don't know what the TIOBE index is, it's a measure of the popularity of various programming languages. Where's the graph? Where's the graph? Come on. There's the graph. There you go. So, Python. Python. The humanity. What's this guy? C++ is on the rise. Interesting. So, basically, this is a measure of all of the, how much a particular language gets Googled, right? Now, I just want to draw your attention to this guy right here, Visual Basic, right? Visual Basic is the programming language which you program macros in Microsoft Office in. You see this jump right here? You want to guess why that happened? Well, it became known that you could use Office macros to perform ransomware attacks. So, whoop, language usage spikes once people figure out that you can use it to launch a ransomware attack. Isn't that interesting? So, anyway, Visual Basic as a language is kind of like, it's a great big meh burger. So, it's like very old and clunky, and like the language semantics are not as clear as something like Java or C#. Like at one point, Visual Basic was a competitor it thought at least it was a competitor for like the same sort of category as Java or C# or something like that, but it's just kind of not as good a language. For some reason they use it in Microsoft Office, probably because it was popular at the time that Office was like created. But anyway, BASIC itself is a very old and venerable language, but yeah. Anyway, so yeah, don't click the email attachment, because that might be an actual honest-to-goodness ransomware attack. But also don't click the link, right? You know, a ransomware attack might be worse than anything else you could possibly have in terms of destructiveness to your own computer. But you know, ask the city of Hamilton whether you should take ransomware attacks seriously, right? You guys heard about the city of Hamilton hack, I presume. I probably talked about it in class. Did you guys hear about it? You guys, are you aware of what's been going on in the city of Hamilton? Okay, so about this time last year, all right, someone at the city of Hamilton clicked a bad link or opened an email attachment or something, and a ransomware attack occurred which hit all of the city's servers. All of them. Like, around, like, I think it might be, I think it's like a slightly less than a year actually. But among the things that were lost, parking ticket database, gone. You didn't have the ability to, like, basically the computer systems for recreation centers were down, so for a period of time you had free access to recreation centers and like City of Hamilton pools and stuff like that. A bunch of medical records got destroyed, like vaccination records got destroyed in this. The computers in the public library system were down for a period of like 10 months or something like that. Like they only recently came back online. Oh man, just everything. Everything was gone. They lost everything. And this happened like last year. And like it was a ransomware attack, and you know, the attacker contacted them and said, you know, I want some money. And they were like, we're not giving you any money. And like as the news articles kept rolling out about like all of the everything that was down because of this attack, like the ransom just kind of kept going up, because I don't think that even the hacker realized how successful the attack had been. But yeah, eventually, like they just refused to pay the ransom, presumably because it was exorbitant, and so they are just having to replace every single server in the city, and they've been doing that for a year now, and I think most things are back online now. But yeah, it's been a whole thing. It's been a whole thing. If you're wondering why your property taxes are going up. Yeah. So that's a thing that actually happened in real life. That's probably one of the worst municipal like hacks. Worst municipal cyber attacks that's ever happened anywhere. And it happened to us. Fantastic. Fortunately, Mohawk College, our systems are completely separate from the city of Hamilton. We were completely insulated from the attack. We suffered no negative consequences. We were a completely isolated system. Same thing with McMaster, I believe. So, you know, we're okay, but holy hell, you could get into the pools for free for quite a while. But anyway, so email links then, right? They will disguise these because it's pretty obvious, right? like, it looks pretty odd. If you see a script tag hanging out in an email link, if you know at all what you're looking for, then that's like plain as the nose on your face. But there are ways of disguising these using HTML compatible characters and that sort of thing, which make it look less obvious, right? They can, but basically, anytime you see an email link and it's like, you know, more than one line long, it's probably script, right? So just don't click on it. And these emails, they look very authentic. One of the ways you used to be able to pretty reliably tell if an email was a phishing email is it would have what they used to call scammer grammar, which is to say the English would be very poor, or perhaps even just middlingly poor, but like worse than any official communication from your bank would ever be, right? These days, because of the advances of artificial intelligence, English grammar is something that's within the grasp of even the least, someone who knows English only in passing. So, you can't really tell so much by the grammar anymore, unfortunately. So, this is my advice to all of you. Anytime you get an email from anything, anywhere, and it's like, you need to do something about your account or something, or you have 10 new people on LinkedIn that you need to do something about or something. Two things you can use, right? Number one, check to see if like information was sent in the email that only LinkedIn would have, like a list of your actual contacts, right? Now this can be problematic because perhaps you don't know who all your contacts are very well, right? Because you can have lots of them. But number two, just don't click on any login links in an email. Just go to the website yourself, right? If you enter the website's URL yourself in the address bar, then you know there's no script in it, right? So that is my advice to you to avoid getting hacked. Just don't click on links in emails, no matter how convenient they look. All right? Sound good? Unless it's, like the one exception to that is it's like, like a two-factor authentication type thing. It's like, I am requesting you to send me an email now, and then 10 seconds later it shows up. That's okay, because you requested it and there it was. The hacker is not going to know when you're requesting two-factor authentication, right? So yeah, does that make sense? So nobody's going to get cyber hacked. You're all going to be good digital citizens, all right? Good. And if you don't think that hospitals and medical organizations suffer from cyber attacks, boy howdy do they. There was a very one of the more famous recent examples of an SQL injection attack, actually, which resulted in a huge data breach, data loss. Are you guys familiar with 23andMe? It's a website which I'm not sure why anybody would do this, because I'm not sure why anybody would want a third party owning their genome. But essentially, it's a service where you spit into a cup, mail it to them. They sequence your DNA and tell you who you're related to, right? And you are 72% French or whatever, right? You have, I suppose, you have vulnerabilities to this disease, that disease, this other disease. Personally, I prefer it to just be, I'd prefer it to be a secret. I don't want to have to worry about it, But anyway, this was a sufficiently popular service. Quite a few people used it, and then they got hacked, and a bunch of people ended up with their actual genomes on the dark web, being sold off to the highest bidder. So yeah, that's pretty gross. Another hilarious and interesting example of, and this is more of a server-side attack than a client-side attack. This is so this is a client-side attack, but you can also attack the server itself, right? Using similar methods, though. Is anybody familiar with the website? I hope not, but anybody familiar with the website Ashley Madison? So this is a website that is used by married people to find people to have affairs with, right? So that is sensitive information. It's like traditional blackmail territory, right? So yeah, they got hacked, they lost their database, and you can imagine all of the blackmailing that happened after that, right? Very, very kind of traditional crime territory, you know. And you'd think that if you were running that kind of a website, you'd keep on top of your internet security a bit better than that, you know. I hope they had their pants suit off. Somebody checked last fall when I brought this example up in class, and apparently the website is still running. So hopefully they fixed their flaws in their internet security. But yeah, so that's like cyber attacks and cybersecurity are real topics, right? This is important stuff, and again, given that you folks will be working for institutions, according to the ostensible purpose of your degrees, you'll be working with organizations that have a lot of sensitive data, so you need to know what not to do. All right? So, shall I show you how not to have that happen then? In PHP, there is a very, 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 very important function called filter input. Filter underscore input. What this will do, depending on the type of filter you select, it will cleanse incoming values so that any script attacks that exist in them are removed or neutralized, rendered useless, so that they do not result in the execution of arbitrary JavaScript inside of your browser. So, to use it, you have to specify a few things. First, you need to specify whether this is coming from a GET or a POST request. Input underscore GET in this case. You need to specify the name of the thing that you are, of the parameter that you're reading. Input 1. And then you need to specify what filter to use. Now the filter that you want to use depends greatly on what type of information you're filtering. Let me take you on a trip to php.net. php.net is your one-stop shop for PHP documentation. If you want to know what a PHP function does or how to use it, this is where you should look, even before you fire up the accursed chatbot. Right? Filter underscore input. There you go. So, filter gives you, let's see here. we have the great big list of filters here. Essentially, the ones that you want are either validation filters or sanitize filters. So if the value that you're reading in is an integer, you'll want to use filter validate int. This is necessary because if you consider, let's see here. If you consider your query parameters up here, I used a form element which constrains that to be of integer type. However, this is the internet, and somebody, some nefarious person, might say, oh, I don't want to put a number in there, I want to put potato. There you go. Let me make this something normal. There we go. I'm in the middle of working on it. That's why it's giving me this syntax error. But this is still accepted by the server, right? The query parameters which are sent are simply characters. There's nothing constraining them to say this is a number, this is a string, this is a Boolean. That's why we have to validate on the server side, right? So, for input 2, filter input underscore get input 2, I'm expecting an integer here, so filter underscore validate underscore int. This way, if it's not an integer, it will tell me that it's not an integer. For strings, we want to sanitize them so that they don't contain script attacks. The filter that you use for that is filter sanitize underscore special underscore chars. Is it sanitize? Sanitize? A. Wait, did it just go, did I lose my highlighting? I did, it must be the other way then. There we go. Filter sanitize special chars. So, there we have it. So now, if we go back, script, you've been hacked. 1, 2, 3. There we go. Oh, I'm not actually printing it. Here. Echo in 1. There we go. There we go. Note, when I print input 1, the filtered variable, the script tags appear in the text of the website, but they are not rendered as HTML. Critically, they are not rendered as HTML. Right? So what has been done here, essentially, the way that HTML works is that it expects angle braces with a particular ASCII value to be sent, or to start a tag, right? So basically, if you look up your ASCII table, sorry for the fuzziness. There they are. HTML files are expecting these characters specifically, ASCII values 60 and 62, to open and close script tags. What the sanitize filter is doing is it's taking these characters and exchanging them for other characters that render the same but are not these character values. So it's swapping out the real braces that work with fake braces that don't work but print the same. Does that make sense? And it's doing that not only with the angle braces but with other like program control characters as well. Right? So by removing these, it's essentially neutering the script. It is nullifying any programming components that existed inside of the script. Therefore, it gets rendered as plain old simple text, even though it looks like it should be rendered as HTML. Does that make sense? So far, so good? So, the long and the short of it, when you are receiving strings from an HTML form, you use filter sanitize special chars. When you are receiving anything else, you use filter validate and then insert the data type. Int, float, bool, those are the usual ones. Make sense? You can also validate that something is a valid email address this way. So, good. Any questions? There haven't been many questions today. Okay. So, the question now becomes handling error states. So, it is not only possible for our inputs to be of the wrong type, it is also possible for them to be missing entirely. Consider what happens when I send something that is missing the first component. I'm just sending input 2. I get, notice, undefined index, input 1. Uh-oh. Whoops. So, filter input has a couple different outputs based on a couple of different error states that can occur. This is a bit unfortunate the way that it does it, because it does it in a very kind of loosey-goosey dynamic programming kind of a way, but nevertheless. So filter input will produce the value if everything is correct. Everything is cool. it will produce false if validation fails, and it will produce null if the parameter is missing. So it can produce null, false, or a value, depending on whether or not the somebody's been messing with the query parameters. These are cases that you must handle. So let's try to handle them. You'll notice, in this case, I didn't provide input 1, and I got a blank up here. Now, a lot of things print as blank in PHP. But the way that we can tell is using tests. Now, because sanitization filters are not the same thing as validation filters, there is not a situation in which the sanitization filter will have a false outcome. Validation can't fail if we're not performing validation. You kind of don't have to validate that strings are strings because everything in an HTTP packet is coming as a string anyways. So we do need to check to see if it's null though. Go. Parameter input 1 not provided. So now, if I go back, I get parameter input 1 not provided instead of errors. I can also still provide information there. There we go. And everything works. Never trust the client. Even if 99.999% of your users are not hackers, 0.001% of your users will be hackers. And it only takes one hacker getting through to crash the whole system. Right? The one way that you can avoid people being able to execute arbitrary JavaScript on your website is by locking down all of your inputs and making sure that you never, ever, ever print anything to the website that hasn't been sanitized. So, now let's discuss our integer input, as that is, that's a validation filter. So let's imagine that I'm a naughty boy, and I put something in here that's not an integer, perhaps place, which is how I usually misspell false. So you can see that where we're printing the integer, it now just simply does not appear. This is because it has acquired a false value. Now, does anybody remember what false converts to as a string in PHP from earlier on today? Empty string. So that's why we're not getting anything. Isn't PHP lovely? So, let's write another one of these. If n2 is equal to null, else if it's equal to null, then the parameter was not provided. If n2 is equal to false, echo parameter is of the wrong type, and only in all of those cases do we print the thing, or only if we bypass those two cases do we print the thing. There we go. So, shall we test it? If we execute the same request again, uh-oh, wait, forgot a semicolon. Gets me every time. There we go. Parameter input 2 not provided. Well, that's interesting, isn't it? Is that true? Is it true that we have not provided input 2? I would ask you to look at the URL. Have we provided input 2? We have. And yet, parameter input 2 has not been provided according to the PHP script. Let's take a look. Can anybody spot the bug? I'll give you a hint. If I execute with a normal number, I get the normal number. If I execute with 0, uh-oh, 0 also thinks that input 2 has not been provided. What could be the matter?
Filter?
No, the filter is correct. It is an integer that we are attempting to validate. One of these things is not like the other. Give up? Give up? You guys give up? The problem is here. Notice which one I used up here. Under weak equality, null is equal to false, which is equal to 0. All of these things are the same under weak equality. So, if the value that I get for n2 is false, I hit the first condition in that if statement. False is equal to null. That is true. So it says parameter input 2 not provided. If I enter 0 as an integer, 0 weekly equal to null? Why, yes it is. Parameter input 2 not provided. Now, this is particularly problematic because 0 might be a very legitimate answer. We have, in this case, a program that will take correct input and call it an error. This is obviously a problem. So, what you have to do is lock it down. Request strong equality rather than weak equality. Then and only then is a 0, a missing parameter prints as a missing parameter, and a parameter of the wrong type is given as being the wrong type. Make sense? For your assignment that has to do with this PHP, you will be required to properly sanitize and filter your inputs. I will be deducting marks if I can get script attacks through. Okay? So, on that subject of assignments, let's see here. Everybody is working on their assignment 2, right? That's due 16th. That's due at the end of the week. Are there any, I went through assignment 2 last week, right? Pretty sure. Are there any questions about assignment 2? If you guys have had a chance to work on it? As always, if you have any questions, please feel free to email me. Please do so before Friday, because over the weekend I don't usually check my email all that much. So, let's see, do we have to talk about assignment 3 while assignment 2 is still being worked on? When is it due? March 2nd? We got loads of time. Okay, I won't go through assignment 3 this week then. We'll save it for next. Wait, next week's reading week. So I should go through it. I should do one of two things. I should either go through it or give you reading week to work on assignment 2. Which would you prefer?
Reading week for assignment 2.
Reading week for assignment 2? Anybody, let's put that to a vote. Anybody want the due date for assignment 2 to be 1 week earlier than it could be? Nobody? Really? All right. Well, in that case, by the power vested in me, by the state of Mohawk College, by the College of Mohawk College, I hereby and forthwith extend the due date for assignment 2 by precisely 1 week. You now have reading week to work on it. With great power comes great responsibility. Please manage your time. That being said, if you are working on it over reading week, I'm not just buggering off to the Barbados or anything over the reading week. I am actually at work doing work, so I will be answering my email over reading week. Just not on Monday, because Monday's a holiday. Thank you very much. It's family day, and I'm going to spend it with my family. Probably. I don't know where else I would be. Anyway, so I guess I don't have to do. We should hold off on going through assignment 3 until we actually get there done. Good. All right, that's that cleared up. Hello everybody. Today we are going to run through some examples in PHP. The first one I'd like to do with you is this example which has been published on Canvas. This turned out to be accidentally fairly similar to the example that we ended class on last time. So I'm going to assume that everybody is going to take a look at the example code that I posted yesterday to the announcements feed to help them out with this, and that maybe we can get a couple additional examples in some practice in before the end of the period. So let me describe this problem to you. Create an HTML page with a form that accepts inputs for a number of rows and a number of columns, as well as a submit button. When the form is submitted, a PHP script should handle the request and create /present an HTML table with that many rows and columns. It says rows and tables, but it means rows and columns, with numbers from 1, 2, 3, etc. up to the number of rows in the table times the number of columns in the table for each cell. So basically, the form tells you how many rows and how many columns. Each table entry is just numbers given sequentially. And that's it. So, for example, if the number of rows was 3 and the number of columns was 4, the table would look like this. Don't worry about styling. When you're finished, submit it in the My Canvas. You don't have to worry about submitting it, as I'm going to be checking it in class. So, hop to, try her out. Again, I highly recommend taking a look at the example code that I posted in the announcements feed yesterday. Are there any questions about this before we get started? Okay. Since you weren't here yesterday, why don't you come with me for a moment, and I'll give you two kind of a quick tutorial on how to do this. Yeah. I'd like to put a diagram on the board that I didn't have time to do yesterday, just to sort of illustrate how the port structure works. How XINF is kind of behaving, right? So, if you consider your operating system, your computer, right? Or the client machine, as opposed to the server, hopefully you guys learned a little bit of this during your networking class, but attached to the client machine is the socket or port interface, right? So when packets are sent, they are sent and received through the socket layer or the port layer. And the best way to think of the port layer is as a series. Does anybody here live in an apartment building? No? But have you been in one? You know the big wall of mailboxes they usually have in the lobby, right? That's a good way to think about the port layer here. A whole bunch of numbered boxes that people are putting packages in, right? And the purpose of a software process is to listen to one of those ports, the specified port. So when we fire up XAMPP and it says, I am using port 1080, we have a software process running called XAMPP. We have a port 1080, and basically XAMPP is watching all of the traffic that gets put into 1080, right? So we then also have our browser. So normally, internet traffic goes out to the network using a specified port number. I'm not sure which port it is exactly. You'd have to ask a networking person. But by saying localhost :1080, we are specifying what port number we want the browser to connect to. So when it sends an HTTP packet, HTTP, it will send it to port 1080. The XAMPP instance, which is listening, then picks that up and receives it. Now, this is exactly the mirror image of what you would do if you were connecting out through the network infrastructure. Right? It does the exact same thing. The only thing is you don't need all of this wibbly wobbly network stuff in the middle. Right? So, XAMPP receives the HTTP request as a properly formed HTTP packet, complete with headers and all of that jazz. It formulates its response. It bounces that response against the socket layer as well, where it is picked up by the browser and displayed as a web page. Does that make sense? So this is basically this is why XAMPP is able to so closely emulate the pager server, because basically it's interfacing with that same portion that that the network interfaces with. It's just that rather than bouncing the packets out to the network, it kind of gets reflected back into the same machine. Does that make sense? Maybe a little? Hopefully a little? Oh, there you go anyway.